Good morning, students. Welcome to Bindu Dhadwal Chemistry Lessons. Our topic for today is from the chapter Chemistry in Everyday Life, and today we'll be doing some basic terms used in medicinal chemistry. What are drugs? Then we'll be doing classification of drugs and interaction of drugs with targets. So let us begin. Drug is defined as a substance or a chemical compound used for the purpose of diagnosis, prevention, relief, or cure of a disease. We can find out if there is a disease, we can prevent from having a disease, we can give relief or cure to the disease. This word is derived from the French word drogue, meaning herbs. Drugs are chemicals of low molecular mass, about 100 to 500 units. These interact with macromolecules and produce biological response within the body. That response is a useful action. The drug can be used for diagnosis, prevention, cure, and treatment of disease. The effect is called therapeutic effect, and the drug is called medicine. The process of treating a disease with the help of medicine is called chemotherapy. But if the effect of chemical is a harmful effect, or if the drug is taken in more than required amount, it may cause side effect and may cause toxicity, then it is called poison. So chemical substance, when it has useful effect, it's called a medicine. When it has harmful effect, it's called poison. The drugs are administered orally, that means taken from the mouth. Intravenous, an injection is given in the vein. Intramuscular, injection is given in the muscles. Subcutaneous, the injection is put below the skin. Sometimes drugs are inhaled and they may also be applied on the skin. Then it's called local application. The route of administration of a drug depends on the physical and chemical properties, site of desired action, and time required for a response. When drugs are classified on the basis of pharmacological effect, drugs may be analgesic, means pain relieving; antipyretic means drugs which lower the body temperature; antiseptic, drugs which kill or arrest the growth of microorganisms; antidepressants, they help in changing the mood, removing depression. Then we can also classify drugs on the basis of action on a particular biochemical process. For example, excess action of histamines in the body causes allergy. If we use drugs to treat allergies, these will inhibit the action of histamine compound, which causes inflammation in body or allergic reaction. Similarly, the drugs which are related to gastrointestinal motility and secretion process, and we use them as a target to treat diseases related to that is stomach and intestine, then they will be classified under one group. On the basis of chemical structure also, we can classify different drugs. Drugs having similar chemical structures may have similar pharmacological activity. For example, all alcohols containing the functional group OH are used as hypnotic, analgesic, and for antibiotic action. Having this general structure, NH2C6H4SO2NHR are called sulfonamides, and they have antibacterial properties. They have common structure. We can also classify drugs on the basis of molecular targets. Drugs usually interact with biomolecules such as carbohydrate, proteins, lipids, and nucleic acids. These will be then called target molecules or drug targets. So drugs will attack these molecules. Drugs possessing some common structural features may have the same mechanism of action on specific drug target molecules. Many enzymes and receptors in cells have common drug targets. Interaction of drugs with targets. Drugs interact with molecules such as carbohydrates, proteins, lipids, and nucleic acids. These molecules, they are known to perform different functions in the body. For example, different proteins perform different roles in the body. Some proteins act as enzymes and act as biological catalysts, that is to speed up biochemical reactions taking part in the body. Then we have certain proteins which act as receptors and help in communication system in body. They help in communicating messages from the brain to muscles or nerve cells or tissues. Then we have carrier proteins which will carry polar molecules across cell membrane. Then carbohydrates and fats are structural part of cell membranes. Nucleic acids impart genetic information in cell. Then enzymes. When enzymes are drug targets, if the molecules which are to be treated involve enzymes, then drug will attack the enzyme and treat the disease. So when enzymes are the drug targets, this can be done on the basis of the function they perform. For example, in case of catalytic action of enzyme, let us first understand how enzymes act in the molecules in the body. So enzymes perform two main functions. Now, the first function of enzyme is to hold the substrate for the chemical reaction. The substrate is held in active sites of enzymes in such a position so that it can be readily and effectively attacked by the reagents. The substrates are bound to the amino acid group of the proteins called amino acid residues on the active sites of the enzyme. So if this is an enzyme and this is its active site and this is the substrate will attack on the active site of this enzyme. So the bond that is formed between substrate and enzyme can be of different type: ionic bonding, hydrogen bonding, van der Waals forces, ion-dipole interaction, and dipole-dipole interaction. The nature of binding will give an indication of the duration of action. For example, whenever a drug is bound by covalent bonding, a prolonged duration is expected. However, these binding interactions should be strong enough to hold the substrate long enough so that the enzyme can catalyze the reaction, but weak enough as to allow the product to depart. So this is the active site of enzyme. This is the substrate. Substrate will get attached and enzyme will hold this substrate. After holding, the second function of enzyme is to provide functional group. So there will be a functional group somewhere else on the enzyme which will attack the substrate and carry out the chemical reaction and change it into product. This function is performed by some other amino acid residues of protein present on the active sites of enzymes, and these provide free functional groups such as OH, COH, SH, etc. to attack the substrate. For example, if amino acid residue is present near the substrate held in active site, then its OH group is free to act as a nucleophile in the enzyme catalyzed reaction. Drug enzyme interaction. This is how the enzyme work in the body. Now, if we want to stop a reaction of enzyme on substrate, we will introduce a drug. which will interact with the enzyme and stop this process. So the main role of drug is to either increase or decrease the role of enzyme catalyzed reaction. Inhibition of enzymes is a common rule of drug action. Many drugs show their effect by modifying the function of enzyme. The enzyme inhibitors can block the binding site and prevent the binding of substrate, or can inhibit the catalytic activity of enzyme. Some of the enzyme inhibitors are useful therapeutic agents and used to treat diseases. For example, inhibitors of enzyme monoamine oxidase are used as antidepressant agents. The drugs can inhibit the attachment of substrate on active site of the enzymes in the following two ways: either competitive inhibition or non-competitive inhibition. In competitive inhibition, the drug will compete with the substrate, and because it has a greater affinity for enzyme, drug will get attached and substrate does not get the chance to attach and perform the biological reaction. So drug will stop the substrate from being acted upon. The substrate and inhibitor cannot bind to the enzyme at the same time. It usually results from inhibitor having an affinity for active site of enzyme where substrate also binds. Therefore, the drug will bind and will reduce the chances of substrate to be acted upon. Second is non-competitive inhibition. In this type, the drugs do not bind to the active site but to a different site on the enzyme, which is called allosteric site. The attachment of inhibitor to the allosteric site will change the shape of the active site, and as a result the substrate can no longer bind to the active site. It is to be noted that if the bond formed between the enzyme and inhibitor is a strong covalent bond and therefore cannot be broken easily, the enzyme gets blocked permanently. In that case, the whole enzyme inhibitor complex is degraded by the body and the body will synthesize new enzyme. Non-competitive inhibition changes the active site of enzyme after binding of the inhibitor at the allosteric site. Receptors as drug targets. Sometimes we use drugs to target the receptors. Receptors are proteins, majority of which are embedded in the cell membrane. This is the cell and the outer membrane. Let us suppose if this small push part of the cell membrane is magnified, we see that this is the receptor protein which is embedded in the entire cell membrane. This is the outer part of the cell and this is the interior of the cell. Now the receptor protein is embedded in the cell membrane in such a way that their small part possessing active site, this is the active site where the receptor will bind the messenger. So small part possessing active site will project from the surface of membrane and open at the outside region of the cell membrane. Now, as we know, in the central nervous system, the information is conveyed and received by neurons. The information is transmitted to the receptor protein by nerve impulse, and the message between two neurons or neuron and muscle is communicated with the help of a messenger. This messenger can be a chemical called hormone or a neurotransmitter. So what happens is this chemical messenger will get attached on the binding site of the receptor embedded in the cell membrane, and as a result the shape of the receptor protein on the inner side will change, and because of the binding the message is transmitted on the inner side of the cell. So cell will perform the function as directed by the brain. As soon as the message is imparted, the hormone or the messenger will leave, and the shape, first when this is attached and message is transmitted, the shape is changed, and when this detaches away from this, the message and the receptor protein again regains its original shape, so that another messenger can act upon this receptor protein to get the work done. So hormones attach to the receptor site, transmit the message, and then leave the site so that a new messenger can come and attach. Now, in the case of hormone or the chemical messenger, this is attached for a longer period of time. So the two types of chemical messengers which are involved in the message transfer can be hormones and neurotransmitters. Hormones are chemical substances which are provided in ductless glands known as endocrine glands. There are two types of glands in the body. One in which the solution is secreted, hormones are secreted through ducts. These are exocrine glands, and the other which are just secreted, there is no duct, are known as endocrine glands. So the secretions secreted by endocrine glands are called hormones. They enter the different parts of the body by the bloodstream, where they activate the receptors which recognize them for message transfer. Then they are not deactivated very quickly. For example, adrenaline is a hormone which is released from adrenal medulla in situations of stress or danger, and will prepare the body for physical exercise to bear the stress. The second type of messengers are neurotransmitters. These are small molecules which help in the transfer of nerve messages. For example, acetylcholine, serotonin, dopamine, etc. A neurotransmitter is released by the nerve endings and get bound to the active site of the closely placed target receptor for a very short time to transfer the message to it. It then departs quickly, unchanged after transferring the message. The receptor then forwards the message to the cell. After leaving the active site, the neurotransmitter undergo degradation and lose their capability of transferring messages. That is, they are deactivated. The degraded products go back to the nerve endings and become active messages again. So in this way, the cycle of message transfer is repeated again and again. From the neuron, the neurotransmitter comes on the receptor, the hormone, the neurotransmitter transmits the message, it leaves without changing in shape but is degraded, and it will again go to the neuron to get activated again, and this cycle is repeated. Now, the mechanism of activating a receptor is same regardless whether the messenger is hormone or a neurotransmitter. Now, based on the activity of drugs, they may be classified into two main types. A drug which stimulates or activates the receptor to initiate a physiological response is called agonist. And a drug which will occupy the receptor without producing any response will be called antagonist, because it inhibits the natural function. It is bind to the receptor site and inhibits its natural function and stop the agonist from stimulating the receptor. So for example of agonist is acetylcholine. It is an agonist for cholinergic receptor. This will mimic or copy the natural messenger and will switch on the receptor. These are useful when there is lack of natural chemical messenger. We give the drugs agonists. And antagonists are used when there is excess of agonist. There are a large number of receptors in the body which interact with different chemical messengers. These receptors have binding sites with different shapes, structures, and amino acid composition, and therefore show selectivity for one chemical messenger over other. The receptor which interacts with specific chemical messenger may differ in its binding site. For example, there are two types of adrenergic receptors named as alpha adrenergic and beta adrenergic, both of which can bind epinephrine. Now, these two have slightly different binding sites, and therefore it's possible to design drugs which will bind better with alpha or beta adrenergic receptor. These are not distributed evenly throughout the body. For example, heart has more of beta than of alpha adrenergic receptor, while tissues have more of alpha than beta adrenergic receptor. So the drug designed to interact with beta form will act on the heart rather than on the tissue. So we can treat the heart by designing a drug which will act on the beta form, because heart has more of beta adrenergics than alphas. So that is all about classification of drugs and action of drugs. If you like the video, please do share and subscribe. Thank you and have a nice day.